going to start off talking about the Arduino, which is a little microcontroller released in Italy back in 2005. I've got one here if you'd like to pass it around. This is actually a compatible, if you like, developed by a Melbourne company called Freetronics. I'm feeding back a bit there actually, aren't I? 8-bit processor, lots of accessories available for it. There's a massive sort of ecosystem that's been spawned from the open source nature of the product. What the Arduino team did in Italy back in 2005 is leverage an existing open source controller platform called Wiring and some software called Processing, integrated it all together to create a tool for education for artists used to learn about control and about physical computing, I guess is the term that people are using now. So controlling simple things in terms of inputs and outputs. And that's the sort of framework that I'm going to use to talk about Arduino today and the 4 exhibits that I've worked on, which use different kinds of inputs and outputs. It's an open hardware product. The design files and the electronic schematics are available under Creative Commons. So you can grab the files and make your own board, send it to China, make derivatives of it that do things that you want it to do, as long as you acknowledge the original developers of the concept. And you can't use the Arduino name itself, and so there's a whole lot of very corny variations of the name, which helps distinguish it. This is a shot from a workshop that I ran with Glenn Barnacle-Barnes yesterday called Hardware Hacking 101. So people were using the Arduino connected to their laptops, programming it by USB, flashing LEDs and so forth. That might sound very glamorous, but if you've never programmed a computer or an electronic device before, it's actually very empowering to do that, and with the help of some really great facilitators who went around the room and helped people move along. We had light chasers running. We used a light sensor to modulate the sound from a buzzer, much like the feedback there. Here we are working with the Raspberry Pi, which I'll address later. So this is a little board here that is a display accessory for the Pi. So this is it's called a Pi face. So this is a sort of selfie for the Pi face, I guess. And this is another accessory that we worked on. So, okay, I'm going to talk about 4 projects. The first one is for the charity Oxfam, and it was a project that they did back in 2008 called Refugee Realities. And it was a week-long simulation of the experience of being a refugee for school-age kids. They had 7,000 people through that experience. It was written up in the New York Times. BBC News covered it. I volunteered some months before to help them out at a technical level, and I never heard anything until midnight on Sunday night when I got a call from the sound designer, who was a student sound designer who was creating the soundscape for what they call the desert room or the desert experience. And she realised that there was no way she was going to be able to get that interactive system up and running when it opened to the public on the Friday morning. So I put together an Arduino-based interface here for her drum machine, which held the sounds of these explosions and so forth going off. So let's just have a look at a video about that project, because it's quite good.
Both here in Australia and around the world. We started brainstorming ways that we could, raise awareness and educate people about refugee experiences. And what culminated from that was the exhibition that you're seeing today, Refugee Realities. So then I would take the group, half the group, through a jungle passage. And it's quite interesting in there, it's decorated like a jungle and it's quite warm as well, so straight away they're in a different environment. And then we take them to the minefield. And we explain that the journey becomes very dangerous. And there are a whole lot of conditions that can make this journey dangerous. They could be attacked by wild animals, they could be shot at. But one of the things that they're going to have to face is travelling through a minefield. The minefield's set up again with soundscape and lighting. And there are small devices on the floor which represent mines, and if people step on certain areas of the floor, a bomb goes off, and they get a badge which flips up into the air and reacts ask them if that happens to them, that they put the badge on, and that will represent the fact that they've been through this.
I've actually realized one of the places people get quite affected is in the desert, in the minefield area. And
So there's no way in 96 hours with no budget that you could pull off a project like that without being able to leverage the ecosystem of open source hardware and all the software and libraries that people have made available as part of that ecosystem. So what I built was this controller, as I've said. What it does is it detects the pressure of the participant's foot by these metal plates, and then it sends signals via a protocol called MIDI, which was developed by Japanese electronic manufacturers in the 80s in the sort of synth hairdresser band era. And that sends this MIDI data to the drum synthesizer which the sound designer supplied, and that's what sends off those explosion sounds. So, you know, a great example of leveraging that ecosystem. So I was able to find some code which sort of did what I wanted it to do. I didn't have to start from scratch. There was already some examples out there, and that really got me started. I built 3 of those boards, so one to go in the project, one for me to keep at home to test or as a spare, and one for the programmer to do his magic. As it turned out, I didn't need to engage a third-party programmer. I was able to figure it out for myself just by swapping a few things around. So there's the inside of it. So you'll notice this isn't an official Arduino, it's just basically the microprocessor running the Arduino software. Let's have a look at an exhibition for the State Library of Victoria about the artist Nick Cave, really about his creative process more than his music, about how he gets his artistic inspiration, I guess. Now, this is a bump in for that exhibition. What you'll notice, this exhibition was designed to tour, and the walls are foam skinned with MDF, and they're very thin, and the DVD players that ran the screens are actually mounted in those walls, and they're completely inaccessible. There's no way you could march around with a remote control and fire up all those DVD players every morning when the gallery's powered up. So I came up with this simple controller, again based on the Arduino, that just sends out infrared commands to the DVD players when the gallery's powered up, and saves, I don't know, tearing the exhibition down each time to start those DVD players up. There's an infrared library for the Arduino that's under very active development for people who want to experiment with controlling consumer type hardware in museum exhibits. It'd be great if we can always afford the professional gear which has lots of external control interfaces, but sometimes we have to use the $30 Harvey Norman DVD player because that's all that we can afford. Let's have a look at the third project. So this is for the Royal Australian Aircraft Museum down at Point Cook, and they have a new exhibit, a radial engine. So it's an aircraft engine that's been sliced open so you can see all the moving parts. The traditional way of controlling a sort of electromechanical exhibit like that is one of these push buttons. Here's one I found in a block of flats near me. You push it in and that slowly comes out, it runs the exhibit and then it stops, and if you want to go again you push it again. They wanted something a little bit more high-tech than that was maybe a little bit more hygienic. So here's the technical curator who was in charge of refurbishing this engine and cutting it away. You can see another sort of museum bump-in shot here, but he's about to trigger a capacitive touch switch embedded in this graphic panel, and that runs the engine for 30 seconds, and then it locks it out for 30 seconds so people can't just sit there and hammer away at it, because obviously when the engine's been opened up like that, there's no oil pressure, so there's the possibility of wear and friction. So let's have a look at a little bit of video about how that works. So after 30 seconds it stops, and then there's 30 seconds where you can't operate the interactive anymore, the exhibit. And the idea is that people will walk away rather than sit there and hammer it away. Now what I was asked to do was add a bit of value to that project. This is the controller I built for it. and I was asked whether or not we can record how many times it gets used. So I added a display, an SD card, and this board writes an Excel spreadsheet to the SD card so the technical curator can import that into Excel and see how many times the exhibit's been used and when. So we know that engine's been run about 13,000 times now, and the most popular day I had 198 uses, and that was the centenary of military aviation in Australia. There it is. You don't have to build these things from scratch in your kitchen/laboratory from, raw printed circuit artwork. You could accomplish the same thing with, boards from third-party manufacturers. Now I'm going to just jump over the AC/DC exhibition, where I synchronised a rock and roll light show with video from a Blu-ray, because I do want to get on and talk about Raspberry Pi. So sorry, AC/DC. This is the Raspberry Pi. So this is a fully fledged computer developed by a UK charity called the Raspberry Pi Foundation. The founders of this charity mortgaged their home to make 10,000 boards. They weren't sure they were going to sell them all. They've sold 6 million now. So it's been very successful. 4 USB ports, Ethernet, HDMI video. What interests me about it for museum applications is it has hardware accelerated video playback. So it does beautiful 1080p video. This is an arty shot from the Museum Art Hotel of some of the stuff that I was given for yesterday's workshop by Element 14, who are the distributors for the Pi. At the end of the year, a accessory for the Raspberry Pi called the Sense Hat is going to fly on the International Space Station. If someone wants to open that up and pass that around. So that's a way of getting kids involved in ICT and in space themes. I've deployed the Raspberry Pi in a temporary exhibition at the State Library of Victoria, where 3 of them ran for 14 weeks without fault. And they're also part of the great shot of enormous place for a screen and this tiny little computer. This was the Victor Hugo exhibition, where I created 3 slideshows and they ran without fault. And they're also part of the permanent exhibition at the RFF Museum, and they describe them as being bulletproof, and they just work, and they should know. But what I want to show you is a project I've been working on where we use video in museums, but we create a more accessible experience. So this is some video from the Māori Language Commission, which they kindly gave me, and they provided me with a Māori transcript and an English translation. So if you're a deaf or hard of hearing visitor to a museum, this experience could be this. So if you want to see some captions in English, then simply turn on the English closed captions. And if you're interested in the Māori language, you're studying it, perhaps you're a visitor from overseas who's interested in Māori culture, you can simply change over to the Māori language, and you'll notice that that doesn't start the video again at the start with a completely different movie. It just switches over on the fly between the 2 different subtitle tracks. That's a good example of what you can do with a $60 computer and having access to the source code. It runs on Linux. All the source code for the video player is open source. I've made a very modest contribution to the source code for OMX Player, which is the video player for the Raspberry Pi. So every Raspberry Pi that now ships has a little bit of code on it, which I wrote, that lets control piece of software, which is the interface between this box and the Raspberry Pi, send commands to the video player to tell it to toggle between the 2 caption languages. So any questions? Yep.
The slideshow screen, were they discontinuous, or could you start them again if you wish to?
The State Library exhibition, which was Victor Hugo from page to stage, that had 3 continuously looping experiences, and that seems to be, most of the projects I work on, they do just loop. I know here at Te Papa I've noticed that you can actually start and stop, but in general, museum videos, in my experience, just tend to loop forever. Any other questions? Alrighty.
I've got a quick question.
Sure.
You're not getting off that easily.
Yep.
So for those of us who are in institutions where simple projects for Arduino or Raspberry Pi?
Yeah, well, I think what we did in the workshop yesterday was a great introduction. We just used just a kit of parts that came with Arduinos and LEDs, and I think with because the Raspberry Pi is designed for the educational market, there's just a huge amount of resources out there targeted at getting started with programming languages like Python. There's, this is a camera board which you can connect up to it. So I'd be looking at those sorts of accessories and the worksheets and the curricula that's been developed in the UK and around the world to help people get their heads around it. All right, thank you.
Thank you very much.